This is a test of your ability to acquire knowledge, and to apply it in different situations. So let's start with a brief recap of basic geometry. Things like squares, circle, and triangles. You probably know about these already, but please bear with me for a moment, and I'll try to be brief. So starting with a square, that's a four-sided figure where each side is the same length and all the corners are right angles. You can calculate the area of a square easily by multiplying the length of the base times the height. In this example, each side of the square is 2 units long, so the area is 4 square units, because 2 times 2 is 4. That'll do for squares. Let's look at triangles. Draw a diagonal line across the square from the top left to the bottom right. This'll give us 2 triangles. The area of the red triangle, ABC, is 2 square units because the area of all triangles is base times height, over 2. We know that angle B is 90 degrees because it's a part of the original square, so ABC is a right-angled triangle. Right-angled triangles have important properties which were discovered by the ancient Egyptians, and used by them to build pyramids. They found that by setting the 2 diagonal corners of their pyramid, they could calculate the length of each side, and create a perfect right angle at the same time. They did this by squaring the distance between the 2 diagonals, then figuring the square root of half of this, and they'd get the exact length of each side. With this, a few pegs and some string, they could create a perfect square of any size in the desert, and the symmetry of the pyramids they built still impresses us today. By using the same method, we can calculate the length of the hypotenuse of our triangle. We know each side is 2 units long, and 2 squared is 4. 4 plus 4 is 8, and the square root of 8 is 2.8284, which is the length of the hypotenuse. Check it on your calculator. Anyway, that's enough about triangles. Let's talk about circles. Draw a circle around the square so that the circumference just touches it at the 4 corners. We know the diameter of the circle is 2.8284, and as the radius is half the diameter, it must be 1.41 units. Given the radius, and by using pi, we can calculate the area of the circle. Pi is a magic number invented by Pythagoras to calculate the quantity of wine contained in a barrel. Mathematicians and academics are still trying to establish an exact value for pi, but we can use 3.14. The formula for calculating the area of a circle is pi r squared, so the area of this circle is 3.14 times 1.41 squared, or 6.28 square units. That'll do for squares. Let's put this together. Draw an equilateral triangle around the circle, with each of the 3 arms of the triangle touching the circle at their midpoints. What is the area of the triangle? To resolve this takes a bit of thought. We don't know the length of any of the arms or the height of the triangle. The only thing we know is the radius of the circle. So, to calculate the area we have to create a number of smaller triangles within the larger one. To do this, drop a perpendicular from the center of the circle to the 3 arms of the triangle where they touch the circle, then another line from the center to the 3 points. This'll divide the big triangle up into 6 small identical triangles, of which we know only the length of the shortest side is 1.41 units. But we also know that the 3 angles of an equilateral triangle will all be 60 degrees, and that the lines from the center will bisect these. Therefore we know 2 of the 3 angles of each small triangle, namely 90 and 30 degrees. The third angle must, therefore, be 60 degrees, and in a 30, 60, 90 degree triangle the shortest side is half the longest, and as the shortest side is 1.41 the longest must be 2.82. With 2 sides of a right-angled triangle we can calculate the length of the third, which will be the square root of 2.82 squared, less the square of 1.41. Stick it on your calculator and you'll find it is 2.44, and with that we can calculate the area of the small triangles. 1.41 times 2.44 over 2. Your calculator will tell you that's 1.72, and as there's 6 small triangles the area of the big triangle is 6 times 1.72 or 10.32 square units. This question requires the kind of out-of-box thinking that can identify great data analysts. In a world where the demand for people who can make sense and draw conclusions from the mountains of data that modern big data systems generate, this kind of thinking is important. The following questions will test your understanding of the topic. If you found it interesting and informative, click the yes button to continue the questions, or you can click no to skip the questions and move on to the next topic.